Hello everyone, welcome back to 3 Deviations. In today's video, I would like to keep talking about average value as a part of our last video on Unit 5. In this video, I'd like to talk about applied average value. So that means like word problems with average value in it. A great way to apply the last subject matter that we were talking about. Now, as we remember, the average value of a function is defined as if I have a curve, loosely defined, this isn't rigorous. If I have a curve, we find its average value, per the name. And this allows us to determine some pretty important quantities in science that can only be determined through integration. So say you have a variable quantity that is non-constant, and it moves like a function, and you need to find its average value. Well, you're going to use average value of a function using integration to determine that value. Okay, so as we said, average value involves integration, and we find the average value as being 1 over b minus a times the integral between a and b of f of x dx. Alright, so let's get started with an example. The linear density of a rod is 16 over the square root of x plus 1 kilograms per meter. The rod is 8 meters long. Find the average density. Now we have SI units here. We have kilograms per meter. And we also have meters. So there's no dimensional analysis that needs to be done for this problem. Now let's draw it out. So the linear density is 16 over square root of x plus 1. Well, we can't really draw that out, but we can draw the 8 meter long rod. And this is what it's going to look like somewhat. And it has a length of 8 meters. And let's choose a coordinate system. Let's say that this is the x direction. If we were in physics and we were working with vectors, this would be the x hat direction. But we're just going to call it the x direction for now. And it has a density, a linear density, let's call that rho, equal to that of 16 over the square root of x plus 1 kilograms per meter. Alright, so now, again, recall that the definition of the average value of a function is 1 over b minus a times the integral from a to b of f of x dx. So now we can apply this. We know our starting point is x equals 0. And our ending point is x equals 8. So what we need to do is we need to sum or integrate that guy starting from 0 to 8. And then we tack on our little fraction at the beginning there. So this is going to give us f of a is equal to 1/8 times the integral between 0 and 8 of 16 over the square root of x plus 1 dx. Now, of course, those of you with a keen eye will know that this is going to be a substitution problem. We need to make a change of variables, and you will see that the most successful change of variables happens when we set u equal to x plus 1. This gives us, when we differentiate u, du equals 1 dx. Now, as you see, this can fit fairly nicely in, and what we shall do now, before even making our substitution, is move this constant 16 out to the outside. So that gives us 1 over the square root of 1 plus x. Again, the same substitution will apply. We also need to change our endpoints. So changing our endpoints entails changing our variables by adding 1, because we are doing x plus 1. This gives us u equals 9 as our upper bound and u equals 1 as our lower bound. When all of the substitution is all said and done, this gives us 2 over 1 times the integral between 1 and 9 of 1 over square root u du. Now the integral of the square root u can be determined using the power rule. This gives us f of a is equal to 2 times 2u to the 1/2 evaluated between 1 and 9. This gives us 2 times 3 minus 2 times 1, which gives us the nice sum of 8 kilograms per meter being our average density of this rod. Thank you very much for watching this video of 3 Deviations. Before watching the next video, which will be in Unit 6, I recommend that you strengthen up on your substitution rule, as well as your anti-differentiating skills with the simple monomials, and your cosine, sine, log, exponential, and all of that nice stuff. The next video will be introductory to integration by parts, where we will begin the reverse product rule. Thank you very much for watching, and we will see you in the